Welcome to the course of Mathematical Physics. I am Dr. Rajkishore Mishra from Maharshi College. Today we shall discuss about functions and graphs. Of course, this is a very basic concepts in mathematics which you have been taught at 11-12 level. We will just make a review and we will then discuss about derivatives, limit, continuity, derivatives, partial derivatives, which are quite essential while explaining physical concepts. So, function is a very important concept, mathematical concept, which is needed while explaining different physical theories. Okay. So, the definition of function you know at your 11-12 level that it is a mapping between two sets. Suppose A is a set, B is a set, A set have certain elements, B set has certain elements which I represent like points. Then a mapping from A to B is a function provided it satisfies these conditions. First of all, it is a relation from A to B. We know that a relation consists of an order pairs x, y. Suppose x belongs to A, x is any element in A. We call x as a variable if it can assume every point or every element of A. And similarly, y belongs to B. Y is a variable while it can assume all the values of elements of B. Okay. Then x y is called an order pair. Okay. And if x are related to y by certain relations, then this set of order pairs is called a relation. And if for any value of x, for every value of x, we have a unique value of y in B. For every value of x in A, we have a unique value of y in B, then only this relation is called a function. Okay. So, suppose x1 is a point in A and it is related to y1 and x2 is related to y2, then y2 is independent of y1. Whatever relations may exist between x2 and x1, the corresponding relation does not exist between y2 and y1, they are quite independent. Okay. So, for every element in A, there is a unique value, it corresponds to a unique value in B, that is y. And we define this function as f, and this y and x are related by this equation y is equal to f of x. We call f of x as the function of x. Let us discuss an example of relation. Suppose our A is a set consisting of 2, 3, 4 and B is equal to say 4, 6, 8. Okay. Then suppose B is related to A, like A is a factor of, then when x is equal to 2, y is equal to 4. So, 2, 4 belongs to this order pair belongs to this relation R. Okay. Similarly, when x is equal to 2, y can be 6 because 2 is also a factor of 6. So, 2, 6 is a order pair which belongs to this relation R, factor of. Okay. Similarly, 2, 8 can be an element of R. Similarly, 3, 6 can be an element of R. Similarly, 4, 8 can also be an element of R. So, in this relation, when x is a factor of y, our elements are 2 4, 2 6, 2 8, 3 6, 4 8. Okay. This is the relationship. So, relation is an order pair x y such that x belongs to A and y belongs to B. Okay. This is the relation, but you can see here in the set A, if we consider element 2, it has corresponding values like 4, 6, 8, many values in B. So, this kind of relation is not a function. Function only when for a particular element of x there exists only unique value of unique element in B. Then only we can say this relationship as a function. Okay. So, every function, as I said, can be represented by a mathematical equation y is equal to f of x. Okay, let us discuss an example. Okay, going to again an example, let us discuss what is domain and range. As I told that the elements in set A which are represented by the variable x, and the element in the set B which are represented by variable y, so that y is related to x by a function y is equal to f of x. So, that for any value of for every value of x there is unique value of y. Then this set of A elements of A, this is called domain of the function. This is called the domain of the function, and the set of all y's is called the range of the function, range R. So, it is called domain, that is called range of the functions. Okay. So, range can be the set B or can be subset of B. Okay. There may not be some elements which are corresponding to x, but A is always the domain of the function f. So, when y is equal to f of x, x belongs to the domain, y belongs to the range of the function. Okay. So, let us start with a mathematical equation. Write a mathematical equation y is equal to root over of 1 minus x square, where x belongs to the real number. Okay. Where x belongs to the real number set. That means x can assume the real number values, there is no imaginary number values, and let us consider only the positive square roots. Only in this function, only in this equation we will only assume the positive values of the square roots of the square roots. That means when 1 minus x square is positive, we will only consider it. If it is negative, we will not consider it. We are defining like this. Then obviously 1 minus x square will be positive only when x square is less than 1. Okay. When x square is less than 1, x will be between minus 1 and plus 1. The value of x will be between minus 1 and plus 1. Okay. So, x can have value minus 1 to plus 1 if only we consider the positive square roots, because you know when 1 minus x square will become negative, its square root will be an imaginary number, and we are considering only real numbers here in this case. And you see this value of x lying between two limits is called an interval. This is called an interval. This is called an interval, and this interval is represented as like this. This is called a closed interval. This is called a closed interval. If an interval is like this, minus 1 less than x less than plus 1, then it is written like this, and okay, this is -1, and this interval is called open interval. Okay. So, in closed interval both the endpoints are included in the interval, but in an open interval the endpoints are not included in the interval. So, here our for this definition or for this particular example of relationship between y and x, when we are considering only the positive values of the square roots, our interval is -1 to +1 and it is a closed interval. Okay. So, the value of x lies between -1 and +1, and obviously the y value will also lie between -1 and +1, okay, because 1 minus x square is less than 1 and whose square root is always less than 1, and it may be plus or minus. Therefore, the y value also will have an interval -1 to +1. So, here domain is -1 to +1, range is -1 to +1, and y is a function of x, because for every x we can have only unique value of y with this relationship. If you put x is equal to say 0.1, then y is equal to root over of 1 minus 0.1 square. So, it is like that. Okay. So, so this is a function and we say y is a function of x. Here y is a function of x and related by the equation root over of 1 minus x square. Suppose we will take another example, y is equal to x minus 1 by x plus x minus 1 by x minus 2, y is equal to x minus 1 by x minus 2. Let us discuss this relationship between y and x, y is equal to x minus 1 by x minus 2. So, here x belongs to the real number, the whole real number, but you can see at x is equal to 2, the value of y does not exist, the value of y does not exist, because the denominator becomes 0. When the denominator becomes 0, it is indeterminate, it does not exist. So, x can have any value of real numbers minus 2. Okay. There it does not the domain has all the elements of real numbers without 2. Okay. So, this is also another kind of your function. So, there are different types of functions, okay, and we can now represent a function graphically. As you have plot a curve in geometry with x axis and y axis as taking in a plane, in taking x axis and y axis, here also our the variable x and the variable y can be taken along x axis and y axis respectively, so that we can plot a graph. Okay. Yes, that another important point here is x here is called independent variable, x is called here independent variable, while y is called dependent variable, because here y depends upon x in this manner. Okay. When x is equal to 1, y is equal to 0. When x is equal to 2 will not exist, say anything 1.2, then y is equal to 1.2 minus 1 by 1.2 minus 2 is equal to 0.2 by minus 0.8, okay, is equal to 1 by minus 1 by 4 is equal to 0.25. So, when x changes, y changes in a definite way according to this relationship, and x is called independent variable and y is called a dependent variable. And while plotting a graph, we will take like geometry, this is our x axis, this is our y axis, this is the origin this is the positive values of y, this is positive values of x, and this is negative values of x, and in this direction negative values of y, okay. And this is the origin O. So, here x is equal to 0, y is equal to 0. So, when our y is defined as function of x, for a variable x, for a value of x, we can have a point say m over along the x axis. So, that OM is equal to x. Similarly, for the corresponding value of y, we can have a value n on the y axis. So, that this is x and this is y, and if we complete this rectangle with x and y, then we will arrive at a point P which represent the order pair x y, which is the element of the function f. So, this is how we represent every point x y of defined by the function y is equal to f of x, and set of all these points for all the variables of x, all the values of x and y, the set of points constitute the graph of y is equal to f of x. Okay. So, there are different kinds of functions, you know. Suppose for an example, I write y is equal to x, y is equal to x means function of x is equal to x. Okay. So, that when our x is equal to 0, y is equal to 0, when x is equal to plus 1, y is equal to plus 1, when x is equal to minus 1, y is equal to minus 1, when x is equal to 2, y is equal to 2, when x is equal to minus 2, y is equal to minus 2. So, if we plot this graph between y and x, then you can see here 0, 1, 2, 3, 4, 5, so on, here minus 1, minus 2, minus 3, minus 4, minus 5, so on, here minus 1, minus 2, minus 3, minus 4, minus 5, plus 1, plus 2, plus 3, plus 4, plus 5, like this. Okay. So, our 0 0 is this point, then when x is equal to 1, y is equal to 1, when x is equal to 2, y is equal to 2, when x is equal to 3, y is equal to 3, when x is equal to minus 1, y is minus 1. So, this is the point, when x is minus 2, y is minus 2, this is the point. So, you can see these are the set of the points and this is the graph is a straight line. This graph represents y as a function of x. Okay. So, if a function value remains same when the sign of x changes, we call the function as even function, otherwise it is called odd function. Means if f of minus x is equal to minus of f of x, or f of x is equal to minus of f of minus x, then this function is called odd function. Okay. So, this is the graph between x and y when y is equal to x. Okay. Now, then our f of x, if f of x is equal to minus of f of minus x, then this function is called odd function, and if f of x is equal to f of minus x, then this is called an even function. Okay. So, always you can see the odd functions are symmetrical about the opposite quadrants. You know, in the graph this is first quadrant, this is second quadrant, this is third quadrant, this is fourth quadrant, and these two are opposite quadrants. So, the graph is symmetrical about the opposite quadrants when the function is odd function. Okay. But when the function is even function, suppose we define y is equal to x square, y is equal to x square, then for x is equal to 0, y is equal to 0, x is equal to 1, y is equal to 1 square is equal to 1. For x is equal to minus 1, y is equal to minus 1 square is equal to plus 1. For x is equal to 2, y value is 2 square is equal to 4. For x value minus 2, y is equal to minus 2 square is again 4. Therefore, you can see the graph is like this, okay, because for x is equal to plus 1, y is equal to plus 1, x is equal to minus 1, y is also plus 1. Okay. For x is equal to 2, y is 4, x is equal to minus 2, y is also 4, y always takes the positive values. So, this graph is symmetrical about the y axis. So, when function is even, why it is even function? Because for x plus x, y is equal to x square, for minus x again, y is equal to minus of x square is equal to again x square. Therefore, f of x is equal to f of minus x. Therefore, this function is a even function and it is symmetrical about y axis. Suppose you take y is equal to x cube, y is equal to x cube, this is again odd function, because when x is equal to 1, y is equal to 1, q is equal to 1, but when is x is equal to minus 1, y is equal to minus 1, q is equal to again minus 1. Therefore, when x changes sign, y also changes sign. So, it is an odd function, and if you plot this graph of y is equal to x cube, the graph will be like this. So, you can see this graph is again symmetrical about the opposite quadrants. Okay. So, when we plot graph of even function, it is symmetrical about the y axis, while when the function is an odd function, it is symmetrical about the quadrants, opposite quadrants. Okay. Now, let us consider different functions, graphs of different functions. Okay. Let us take an absolute value function. If f of x is equal to mod of x, it is called absolute value function, absolute value function. What is mod x? When x is less than 0, mod of x is minus x. When x greater than 0, mod of x is plus x. That means, whether x assumes negative value or positive value, mod of x is always plus x, because you can see for x is equal to 1, mod of x is equal to x, because x is greater than 0. So, it is equal to 1. When x is equal to minus 1, mod of x is equal to minus x, because here x is less than 1, sorry, x is less than 0. When x is equal to minus 1, it means it is less than 0. Therefore, mod of x is equal to minus of x, means minus of minus 1 is equal to plus 1. So, this is called absolute value function, and if you plot the graph of absolute value function, here this is x and this is y, the graph will be like this. Unlike y is equal to x, where the graph extends to the third quadrant, here for x is equal to plus 1, y is 1, for x is minus 1, y is also plus 1, for x is equal to 2, y is plus 2, for x is equal to minus 2, y is also plus 2. So, the graph is symmetrical about the y axis. This is called absolute value function. Okay. Now, let us consider a function f of x is equal to 1 by x. Let us consider f of x is equal to 1 by x. Then this graph at x is equal to 0, function value does not exist, it is infinite, 1 by 0. I mean, when denominator is 0, the function is not determinate. So, this is called rectangular hyperbola. When x goes to infinite, y tends to 0. This is y, this is x. Y is equal to f of x is equal to 1 by x. Okay. When x approaches 0, y goes to infinite. When x is negative, the graph occurs in the third quadrant again. So, that when x tends to negative, infinite y tends to 0, and when x tends to 0 y tends to infinite. So, this is a kind of graph f of x is equal to the graph of the function f of x is equal to 1 by x. Okay. If the function gradually increases value, the value increases as we increase x, then it is called monotonically increasing function. But if f of x decreases as x increases, then it is called monotonically decreasing function. So, for example, if y is equal to 2x plus 7, if we plot the graph, then at x is equal to 0, y is equal to, this is x, this is y, at x is equal to 0, y is equal to 2, then again the graph goes like this. And you can see as x goes on increasing, the value of y is also increasing. This is called monotonically increasing function. But what about this function 1 by x? When you increase the x, y gradually decreases. This is called monotonically decreasing function. Okay. So, if x2 is greater than x1 and function value of x2 is greater than function value of x1, then we say it is monotonically increasing. Okay. For example, here y is equal to 2x plus 7, means y is a function of x is equal to 2x plus 7. When x is equal to 1, the function value of 1 is 2 into 1 plus 7 is equal to 9. When x is equal to 2, the function value f of 2 is equal to 2 into 2 plus 7 is equal to 11. So, when x is increasing from 1 to 2, function value is increasing from 9 to 11. So, it is a monotonically increasing function, but here when x is increasing, function value decreasing. So, it is monotonically increasing function, monotonically increasing function. But if x 2 is greater than x1, but function value of x2 is less than function value of x1, okay, then this function is called monotonically decreasing function. It is called monotonically decreasing function. Okay. So, we will discuss more about different types of graphs of different types of functions. Okay.